Welcome to part 3 of Competency 17. In this video, we will continue to work with probability theory and tests. Number 9, for the standard normal curve, what is the area to the right of z equals 1.3? Okay, I know because they're asking for standard normal curve, okay? And I see no mean, and I see no standard deviation. Okay. And there's no N for number of or sample size or population size, anything like that. And they just give me a Z value. I know I need to have second vars, which is the distributions. Now I need to go to number 2. Okay. All right. So there's an upper and lower in my calculator already. But I know that my lower is my Z value, and I'm looking for everything to the right of it, everything that increases, okay? So my lower is 1.3. Now, what's my upper? Now, if you watched other videos with me or you had this in school, if you remember, you type in 1, second, and that E right there with the division, okay? And then 99, okay? Right, then you enter, and because it says standard normal curve, that's that bell curve, normal curve, bell curve that you used in class, okay? And that one was always a mean of 0 and a standard deviation of 1, okay? You just go with the normal because it says standard. It's the one that your professor would have popped the picture out probably and drawn on it to give you examples before you got into detailed populations. Okay. All right. So let's go. Enter, enter, enter again. There you go. Let's see which one matches the best. And I would go with C. Okay. They didn't tell us how to round, but we can see from what we have what's the best choice. Okay. All right, so let's see. Number 10. The amount of soda dispensed in a paper cup of an automatic machine has a mean of 6.2 ounces and a standard deviation of 0.4 ounces. What percent of all the paper cups will have between 5.7 and 6.0 ounces of soda? Okay, because we are given a minimum and maximum, a range, okay, that tells me that those would be our Z scores. And they were using the same distribution to find the percent. And again, notice there is no N. They didn't give you the number of the population sample size, okay? All right, so that really tells me what I need to do. So second vars, go down to number 2 again. Now, I do have an upper and lower, so 5.7 and then 6.0. Okay, now I do have a mean I need to put in 6.2 and then our 0.4. We enter again, and enter. Okay, now we're looking for a percent. So what do we do? If you can't see it quickly, just say times 100. If you remember how to do that. Okay, now do with a little bit of rounding. Do a little bit of rounding. Here we go. Option D. Okay. All right, let's move on to number 11. Okay. All right. So number 11 says in thousands of dollars, the mean salary of high school teachers in Texas is 52 with a standard deviation of 3. What percent of these teachers earn more than 49,000? And we are going to round to the nearest. Looks like they've already given us some rounded options, but 1%, the 10th of 1%, which is okay. All right, so what do? Well, the first thing I need you to note is this. This actually is in thousands of dollars, but notice they stated this business right here. So what does that mean? That means here we're only gauging against the 49, okay? We're not going to type in anything different. So how do we deal with this? Well, Okay, and also I need to explain when we get there, I'll explain to you what that 49 means for us, okay? All right, so I need to use the same distribution. So vars, second vars, okay? Go down to number 2. Okay. In thousands of dollars. Okay, what percent of the teachers earn more than 49,000? More than 49,000. Now you may not remember this from your coursework, but because we're conducting a comparison and we are saying more than this, okay? And we are not receiving a z value, okay? This is an actual number of comparison of 49. We need to say that our lower is 49.5, and we can get away with the point 0.5 because we are being consistent, because this is doesn't say 42,000, I mean 52,000, it says 52, and the standard deviation is not in thousands. So we need to convert this to 49.5, which is 49,500. Okay, right? You do this because you are absolutely not including anything near or around the 49,000. Okay, now I'm not explaining it as well as an instructor would have. If you're a little confused, there's some good videos out there that you could watch, or go back and look in your notes from high school or college. Okay, that being said, let me move on. 49.5. And we enter again. What is our upper? The 1 second E99. And we enter. We were given a mean of 52 and a standard deviation of 3. And here we go. All right, now we need a percent. If you want to, you can say times 100 if it makes you feel better. Okay, that way your eyeballs don't have to get crossed and you don't have to do any thinking. And we only have one option, which is B. There you go. Okay. All right, so let's look at number 12. In a normally distributed population, okay, which tells us we can use the items in our calculator, okay? The mean is 24 and the standard deviation is 4.8. Which one of the following is completely correct with reference to the distribution of sample mean of all samples size 64? Okay, notice they're talking about distribution and sample means. Okay, what can we say is true? Okay, first off, I can tell you right now that our mean will stay the same. The population mean and the sample mean will be the same. It's one of those things that they taught you in school. Okay, this is something you just got to know this knowledge. Okay, all right, so we can mark that out. Oh, no, I don't want to mark that out. We can mark anything out. I'm sorry. We can mark anything out that doesn't pertain to the correct mean. The mean doesn't just change to a small that's like 3. It wouldn't do that, which would maybe that would be changing the deviation. I don't know. But that doesn't make sense. So B and D just flat don't make sense. Okay, now, if the mean doesn't change, I can tell you right now that that standard deviation has to change. Okay, that's the one thing that does change. Well, if it changes, then we know just by knowing the property that A is not correct. Everything doesn't just stay the same. Something had to change. Well, it's a standard deviation. Well, what is the new deviation? Okay. All right. So notice I'm changing my notation. Okay. All right. And what is it going to equal? Okay. We're going to use this already the given. This is why they gave us the standard deviation. You take the standard deviation from your actual population. Then that's a numerator, your denominator will be the square root of the sample size. Okay. Now we pop that in the calculator and see what comes out, right? We're trying to verify that C is the correct option. Okay. Right. So alpha y equals enter, and then my population deviation, and then I go down and I have second square root 64. Now let's push enter, and there we go. C is verified. Okay, this is the last question in this particular video. I wanted to thank everyone for the support. It has been amazing. I have seen an increase of video watching. People have told me they're passing. Congratulations, guys. That's amazing. And some of you said that you did it on the first try and that the videos are helping. I'm so proud of you. And it's amazing of how many people are sharing and liking the videos and the subscriptions. Kudos to you guys. You're the best. Happy testing, everyone.